TTL Computer 2. Today we'll be taking a look at our final card of our major card build out for TTL Computer 2. And this is going to be our communication serial card. And we'll just start out with a really quick review of our simulator circuit design, which we're looking at right now. And you can see we have our address bus buffers. We have our control signal buffers, and we have our data bus buffer and driver 245 chip. Then we have our address decode comparator, which decodes for 2080, which is our base address for our UART. Then we just have a little bit of a logic chip to do the encoding for our write signal and our clear signal for our serial UART. This is our 16550, which we've looked at before. We can see we have our oscillator signal planned for here. We have our two output user-controlled output signals from the 16550 that we're going to use as transmit and receive indicators ultimately. And then I have a chip here that I'm using to simulate the FTDI chip. Okay, so that's our serial card design in our simulator, which we looked at in our prior video. Now let's jump over to our schematic. Okay, so this is our schematic design, and this is virtually again identical to our simulator design, right? We have our address bus buffer chips. We have our control signal buffer chip, and we have our data bus buffer and driver chip. And then the only thing that's new here in the schematic is that we've added our 33 ohm impedance matching network. We have our address decoding chip. It's the same configuration as our simulator. We have our signals encoding chip for our write and our clear signal, and our master reset signal for our UART. And then we have our FTDI, just a 6-pin header. And that's what we use the IC in our simulator to represent this. But that's our FTDI connection. And then we have our 16550 UART chip. And again, this is wired up exactly the same as in the simulator. And we have our two LED indicators that are going to be used for our transmit and our receive indicators. So that's that. And then lastly, we have our oscillator. We have our oscillator chip that we're going to be using, our opulent module. And this is at a 1.8432 megahertz chip. And that sounds like, well, that's a pretty weird frequency, but that's one of the recommended oscillator frequencies to be used along with the 16550 because there's two special registers on the 16550 that you use as a divisor that divides down that oscillator frequency to specific baud rates. So that is why we use that strange odd frequency, but it gives us makes it be evenly divisible to get to our baud rates that we desire for the UART. Okay, so that's our schematic. Those are our active elements, and then likewise we have the passive elements, right? We have our decoupling power capacitors, our bypass capacitors for each of our chips. We have our power indicator, right? And then we have our card edge connector. And the only thing, so this is the same as the card edge connector for our memory card. The only thing that's different there is that the memory card does not include our clear signal, our reset signal, but that has been added to each of our expansion slots. And this serial card will live in an expansion slot, and we're going to want to have access to the clear signal. Okay. So those are the two sheets of our schematic, and let's jump over to our PCB design now. And so this is much the same as our other cards. It has the same uh, board outline, which is 200 millimeters by 150. We have our card edge connector. Now, what I actually did here was, again, since our memory card is kind of our pattern for all of our expansion cards, I cloned I cloned the memory card project as a starting point. So that meant I didn't really have to do a lot of the component placement and the routings, right? So I got the card connector, I got all of this card connector routing and the routing here kind of for free. And then I deleted all the rest of the stuff and started my schematic work. So a lot of the routing was already done for me. But so most of our routing is done on the top layer. This is again a two-layer board, and you can see we have our input signals being brought up and around. So and then being brought down to the 16550. And we can see that here as the signals being brought down. Okay. And so not a lot of surprises here. A little bit intricate to do the wiring. Um, a key thing is that you really just have to look at the components and kind of visualize the routing in your mind, and then do the component placement. So it took me a couple of tries to get the component placements correct for the routing, but once I did, the routing was went pretty smoothly. Okay, and so you can see that we have a couple of our power decoupling capacitors here, here, and here. All of our bypass caps for each of our components, and we have our oscillator kind of isolating our oscillator a bit, so it's kind of not close to any other signals as best we can do. And then we have our transmit and our receive indicator LEDs that we will drive by through software on TTL computer too. We'll actually drive setting setting those indicators. Okay, so that is our serial card, and let's take a look at our 3D representation. And there we have in all its glory, our final major card for TTL Computer 2, our serial card. And you can see we have the FTDI cable header there. Um, so what I'm intending to do is that there'll be just enough space to use that header, and we'll see later on that we'll bend the wire, and then the FTDI cable will just come out this way and get connected to our computer enclosure. But that should be fine. And what else? That's it. So we have all our silk screening there, and we are good to go. So this should be, I want to do one final set of checkouts on this board. I've also done already a checkout for design for manufacturing, which runs our Gerber file through some extended checks on JLC PCB to make sure there's no problems for manufacturing. That's all being done. So just our final checkout I'm going to do, and then this will be off to fabrication. So this is getting to be an exciting time for our project. And yeah, hopefully we will very soon get to see the monitor kick off for our hardware build out, and that'll be really exciting and really bring us to the end of the first phase of our project. And I think at that part, that break point, we will kind of we'll shift our focus to software development for a time. But anyway, that's it for today. Until next time, thanks for watching.